Good morning, all of you. In yesterday's class, I solved one problem, right? What is that? There is little correction. In option, they have given minus 10 kilocalorie, but actual answer should be 10. So that's what I'm giving you again. So make it correction there. So this is a question or problem which I solved in the last class. This question was like this. Find the external work done by the system in kilocalorie when 12.5 kilocalorie of heat is supplied to the system. Heat is supplied to the system, and the corresponding increasing in internal energy. This problem already we have solved. Just plus to minus we have to change. Internal energy is 10,500 joule, and they have given J is equal to 4,200 joule per kilocalorie. Okay, this was what the question is, and they have given in the book option like this: 15 kilocalorie. Second one is 12.5 kilocalorie, and third option is they have given minus 10 kilocalorie, and fourth one is 7.5 kilocalorie. Yesterday we wrote minus, but actually this option should be plus. Okay, so this answer should also come plus. So let's see here how it is one more time. So what is given here? Given external work done, he is asking you. So delta W is equal to question mark. Heat supplied, so delta Q is given, that is how much? 12.5 kilocalorie, and increase in energy they have given, delta U is equal to 10,500 joule, and if we will convert into kilocalorie, then 10,500 divided by 4,200, and this you got 2.5 kilocalorie for conversion. Yes, and then delta Q is equal to delta U plus delta W, and therefore here it is 12.5 is equal to 2.5 plus this delta W, and therefore this delta W is equal to 12.5 minus 2.5, and hence just delta W is equal to 10 kilocalorie. So change this, just keep the sign plus there, because external work done is there, so it should come plus, not the minus. By the system, no, work done by the system, right? Okay, okay, good. So let's move ahead, and I want to tell you one more time sign conventions, how to keep it in mind. Sign conventions, I'm giving little diagrammatical way for your understanding. So see here, this is a system. Okay, 1 minute. How to keep it in mind? Sign convention. Number one for delta Q. Delta Q sign. how to keep it. Already I have given you a box, but then also again I am giving you one more time. So see, this is a diagrammatical way how to keep it in mind, delta Q sign. So let us suppose this is a system. This is what? System, right? And if you have supplied heat, what we supplied? Heat we have supplied. I am drawing one candle. Heat supplied. Heat supplied means delta Q is positive. This is what? System. Okay, what is this? System. And you have supplied heat to this, then delta Q sign is positive, right? This is A case. Then next B. Again I am taking system. Okay, this is a system. And now from this heat is taken. So I am not drawing again any candle. Okay, just I am writing here heat is taken out. Just this is just for your understanding. Okay, so what is this? Just a funny way to understand. This is a system and we have taken out heat whatever it is supplied. So therefore just I am drawing some heat diagram. Okay, something like this. Okay, heat taken from system, arrow you see, arrow. Then delta Q is what? Delta Q is negative. Understand? See, it is very nice and funny way, hai na? So here I have shown you little expansion, hai na? There is what? Expansion, or even we can say what? There is a heat we have supplied. No need of expansion all. Just heat supplied. You see this arrow from here to here, and heat is taken from the system. So this is a heat. So this is delta Q is negative. This is delta Q is positive. Understand? Next one. Next one. Second point, that is for delta W. When is delta W positive and when is delta W negative. So again for this delta W sign, so that you will never forget. So this is a gas or system, we can say gas or system, and okay, so what I am doing, see, the funny way, to understand, so that you will understand how it is. That this is a gas or system. So if this is expanding, what it is doing? Expanding. This is expanding means what? It is becoming little big. System ये देखो expand हो गया ना? Yes. Gas comma system. What happened here? It has expanded, है ना? Can you see? This has expanded a lot. Yes. System expands. Expansion. Then delta W is equal to positive. Delta W is positive. Expands. Gas expands. है ना? Then what happens? Gas of system expands. Then there is delta W is positive. Right? This is what? One way to keep it in mind, delta W sign. Next one, in this delta W sign only, see. So I am writing here A, okay? And here also or this only, A bit only. Suppose this is a system, okay? What is this system? And here is this is what? System, and this is what? Surrounding. So what is this? System is kicking this surrounding, है ना? So work is done by the system on surrounding. है ना? Work is done by the system on surrounding. Then also delta W is equal to positive. है ना? ये इसको लात मार रहा है. He is kicking the surrounding, means work is done by the system on surrounding. Delta W is positive. Right? What is this? Delta W is positive in this case. Understanding? Is that clear? So that you will never forget now this. System is doing work on surrounding. Or else if you want one more, you see here. One more diagram for you. This is a system and this is a surrounding. Who is this? System. And this one is surroundings. तो यहाँ पे भी देखो आप कौन किसको पुश कर रहा है. System is pushing the surrounding. Yes or not? So this is what, again here also what, delta W is positive. Work is done by the system on surrounding, then it is positive. Understand? These diagrams you keep it in mind. System and surrounding. Clear? Next one. Next B beat when it is negative. Now when it is negative. So see here, this is a big one, right? As in the first diagram I told you, this is expanded, hai na? Expanded. I am taking that only, expanded one. And if it is contract, then work done on the, or gas or system compresses, we can say. Gas or system compresses. Initially like this, hai na? Initially it is like this, gas or system, and then finally what happens? It compresses. What happens? It compresses. Hai na? Can you see? Yes, now understanding? Compression. Gas, comma, system compresses. Then what? Delta W is negative. है ना? Delta W is negative. Compresses. Delta W is negative. Or you can say, see here, B beat only, or suppose here, now as we have seen the system and surrounding, so I am taking this as a system. Yes, this is a system, and you see this is the two legs are down now for this. This is what? System. And now here is the surrounding, and this surrounding is kicking this system. This is what? Surrounding. Then work is done. Surrounding is doing work on the system. Then delta W is equal to negative. है कि नहीं? अब समझ में आ रहा है? Surrounding and system. Then delta W is negative. Work done on the gas. है ना? Work done on the gas. Work done on the gas. Then it is negative. इस पे किया है ना? इसको लात मारिए, right? So here it is, gas system compresses, right? Gas or system compresses, or work done on the gas. In this case, delta W is positive, means system is doing work on the surrounding. है ना? System is doing work on the surrounding. System is doing work on the surrounding. Or you can push it here. Push or this kick. Anything is same. Either this or this. Next here, expansion. है ना? Gas or system expands. Then delta W is positive. I hope you understand now perfectly this one. Right? Work done on the gas or system. Work done on the gas or system is always negative. है ना? Next one. Next one. Internal energy. Next one is what? Internal energy. So third one, that is delta U. Delta U. Now suppose now here it is a system and its temperature rises. Temperature rises, internal energy increases. Temperature rises, internal energy increases. Then temperature rises, internal energy increases. Temperature rises means what? Shall I draw on thermometer to understand? Or you will understand temperature rises? No. So I have written directly here. Then delta U is positive. Okay. And this is A for this. And B also I am drawing here only without wasting more time. So here it is temperature decreases. Temperature decreases. Then internal energy decreases, है ना? Temperature decreases, internal energy also decreases. Then for this, delta U is equal to negative, है ना? You can write this part below this, okay? Below this, so that you will understand better. So delta U is positive here. Delta U is positive in this case. And in this case, it is this. Delta U is negative. Understand? So now I think you don't have any problem. You can go through this and the sign conventions are perfect now for you. Okay. Okay, good. So let's move ahead. Next one, next topic, that is isobaric process. First one is what? Isobaric process. Isobaric. Isobaric means what, Ray? Isobar. Bar means what? Pressure, है ना? So pressure remains constant. Then that is what your isobaric process. The process in which pressure remains constant. Already we have learned this in the first class only, right? So if you want one more time, I am writing the definition of this, that is when, because this is detailed study of this process, when a when thermodynamic system undergoes a physical change in such a way that its pressure remains constant, its pressure remains constant, है ना? Already I told. Then the change is known as isobaric process. Then the change is known as known as isobaric process. Okay, write down with me, always write with me. Okay, because if you will write with me at the same time, if you will understand, that will be better, right? So see here, what is the equation of state for this isobaric process? Try to understand. Isobaric equation of state for this process. What is that equation of state? Let's see. Equation of state. So here, volume and temperature changes, P comma T, or P and T changes, P and T changes, P remains constant. Yes or not? P remains constant. Already we have learned these thermodynamic variables: pressure, volume, temperature. These three are the what? Thermodynamic variables. Out of that, P and T are changing, but P is remaining constant in which process? Isobaric process. So, which law is obeyed here? Charles' law is obeyed. Hence, Charles' law is obeyed. Charles' law is obeyed in this process. What is Charles' law? What is Charles' law? What is the Charles' law? You know, at constant pressure, at constant pressure, phi is proportional to T, and therefore phi by T is equal to constant, and therefore P1 by T1 is equal to P2 by T2 is equal to so on is equal to always constant. This is what your Charles law, and that is what equation of state in which process? Isobaric process. Got it? Okay. Note down. Right. Let's move ahead. Now, next one. What is the indicator diagram for this? How will be the indicator diagram? Indicator diagram means what? The diagram which indicates what is going to change in the particular process. So indicator diagram, how it will be, let's see in this process. So first one, I am taking graph A for isobaric expansion. Who will tell me what is meant by isobaric expansion? Isobaric expansion means if expansion takes place by keeping pressure constant. You are keeping pressure constant, but then also there is expansion. That is what isobaric expansion. And B beat I am taking, that is isobaric compression. Isobaric compression. So let's plot the graph. Yes. You see how is the indicator diagram? This is pressure versus volume. Yes. and this is what the expansion curve we can say. Why? Because you see, if suppose this point we are taking, there is no change in pressure, same pressure, but volume is changing. Volume is changing. So if we will find out slope, slope is equal to what? dp by dv, है ना? p2 minus p1 by p2 minus p1. dp by dt means what? p2 minus p1 by v2 minus p1 is equal to 0. Why? Because this is p1 is equal to p2 is equal to p, and here it is what? v1 and v2, but it is of no use. Even though it is having value, numerator is only 0. Yes or not? So therefore you are having, for this, slope is equal to 0. So in mathematics, you know slope how to find. Slope is equal to y2 minus y1 by x2 minus x1. Here you write y1, okay? y2 minus y1 divided by x2 minus x1. This you know, this is a basic formula, and from this only we have calculated the slope for here, and there, that's what slope we are getting 0. Next one, see here graph 2. Let's change the color. Okay, so in this you see, in this process isobaric compression, what will be the case? In this isobaric compression, again you are getting a straight line only. Why? Although it is a compression, then also you are having pressure constant. But you are having constant, pressure is constant. So here you are getting graph like this. But as this is a compression, the diagram, what you can say, direction is how? Like this, right? So here also you see, this is a pressure and here is a volume in the indicator diagram. You can keep arrow like this. And so here also, if we will find out slope, what you will get? Again slope. Slope here also 0. What is your slope here also? 0. P2 minus P1 by V2 minus V1 is equal to 0. Right? Here also same thing, isn't it? Right? So here you can see V1, this is V2, or you take here V1 and here V2, because it is compression, no? Choice is yours. Even if you want here, you can keep here V1, here V2. Choice is yours. Okay. Choice is yours. Not an issue. Anything you can denote. Even Vi and Vf also you can write there. So I am writing here V2, there it is V1. Because it is initial state now. So it is more volume, and then here it is decreasing. Because it is compression. Clear? Okay, so let's see what are the properties going to change. That is, what is delta Q, delta W, and delta U in this isobaric process. Okay, so what is going to change in this isobaric process, right? So let's see. So what happening in the isobaric process? See, in isobaric expansion, in isobaric expansion, isobaric expansion means what? We are heating, है ना? When we are heating this process. So see, temperature, next one is volume, next one is heat. Now when you are heating, temperature will increase or decreases? Temperature increases, and volume also increases, okay? And heat flows into the system, okay? Flows into the system. Okay, sir, understood. When we are heating isobaric expansion, then temperature increases, volume also increases because it is expansion, and heat flows into the system. Now you tell me what will be the sign. Okay, very simple. Very simple. Very simple. Who will tell? Who will tell? Let's see. Temperature increases means delta U is positive or negative? Delta U is positive. Volume increases means delta W is positive or negative? Delta W is positive. Heat is given to the system. Heat is given to the system means delta Q is positive or negative? Delta Q is positive. Okay, understood. Next one. Next one. Second point. In isobaric compression now. In isobaric compression. Isobaric compression. What happens? That is cooling, we can say. What is this? Cooling. Now टेम्परेचर डिक्रीजेस इंक्रीजेस कूलिंग में टेम्परेचर क्या होता है? इंक्रीज होता है, डिक्रीज होता है? डिक्रीजेस है ना. सो टेम्परेचर डिक्रीजेस. Okay, temperature decreased. Volume increases or decreases? As temperature decreases, volume also increases or decreases? Decreases है ना. So volume also decreases. Next, heat flows out of the into the system, out of the system, out of the system. So heat is given out, we can say. Heat flows out of the system है ना. Heat flows out of system, out of system. Now you tell me, what is the sign for this, and for this? Let's see. Temperature decreases. Delta U negative. Why? Because delta internal energy decreases. As temperature decreases, internal energy decreases. Anduke negative. Volume decreases. So delta W is what? Delta W is also negative. Here delta Q, heat is given out of the system, means heat is given out of the system, not heat is supplied. Heat is taken out. Candle का diagram याद है ना. तो delta Q is negative. Clear? Understanding? Yes. Okay, next one. So all is negative in this case. So next one, that is third point in this process. Specific heat of gas, which is also very important. Specific heat of gas during isobaric process. During isobaric process, that is CP. CP means what? Specific heat at constant pressure. CP is what? Specific heat at constant pressure, because this is isobaric, no, so pressure is constant. So CP is equal to F by 2 plus 1 into this R. This value you keep it in mind, where F they will give you. F is what? Degree of freedom. And next one, in this isobaric process, bulk modulus. Bulk modulus of elasticity. This is also important. Bulk modulus. This is just keep it in mind. Bulk modulus of elasticity. This K value is equal to 0. Why 0? Because bulk modulus formula is what? I will give you. Wait. Bulk modulus of elasticity. So this formula is what? You see here. Bulk modulus formula is like this. Delta P, that is change in pressure divided by change in volume by original volume, like this. If change in volume or this delta P is only 0, as delta P is 0, because change in pressure is 0, so therefore you can write as delta P is equal to 0. If someone will ask you what is bulk modulus formula, you can tell him like this: delta P by change in pressure by change in volume by original volume. Okay, got it? Right? So note down this fast. Okay, finished, noted. Okay, I'm erasing this part. Right. So next one is what? Work done in isobaric process. That is the next point. Work done in isobaric process. This is very important. Work done in isobaric process. How it will be? So we know the formula delta W is equal to integration of Pi to Vf. Already I told you this. P into dV. So if we will solve this, what we are getting? P into Pf minus Pi. This is what your delta W. Hai. So here as P is constant, okay, because P is constant in this process, right? Because isobaric means what? Work pressure is constant, no? So you are getting like this. Next, now we know from ideal gas equation PV is equal to nRT. So therefore, if I want P into Pf minus Phi, then what I should get here also? nR into Pf minus Ti. Pf minus Ti. So therefore, delta W is equal to, in this case, nR into Tf final temperature minus initial temperature, and therefore delta W is equal to nR into delta T. So anything formula you can use this nRT, and here also nR delta T. Anything is okay. You can use according to the problem. Right? Clear? Yes or not? Okay, so this is work done till this moment of time. We have finished, that is work done in isobaric process. In tomorrow's class or in next class, we will learn examples of isobaric process and what you can say plot in isobaric process. So these examples and that we will see on or in tomorrow's class. Got it? Right? So revise once thoroughly, and let's stop here. Enjoy the day. Bye.